My name is Ryan Frias. I'm a software engineer at Skywalker Sound. I've been there for a little over 11 years now in different parts of the building. For those that don't know, Skywalker Sound is a post-production sound company, that is. We've been in the business for over 40 years doing sound for film, video games, TV shows, you name it. We're located at Skywalker Ranch, which is just north of the Golden Gate Bridge. Has anyone been there before? Awesome. We're honored to be here today, so thank you for having us. I'm here to talk to you about processing audio post-production deliverables at scale with microservice architecture. Mouthful. Let's go into it. Okay, so in the past 5 years, we've seen an enormous growth in both content production and the audience that content is delivered to. In general, more media is being made at incredible scale, and every company seems to be producing media, such as Disney, Warner Brothers, Netflix, Comcast, Amazon, and so forth. At the same time, the rise of direct-to-consumer streaming has driven faster adoption of technical formats, codecs, and standards. So when you combine this higher number of titles with more languages and in more formats, it creates a really big matrix of hundreds, often thousands of audio deliverables to create for a given title. So why are there so many versions, you might ask? In the world of post-production sound, this means that for each language, making unique soundtrack versions for different purposes, like the web, your phone, mobile, obviously, DCPs, archive, home theater, marketing, audio description, different loudness versions to hit different territorial requirements, encoding formats, and so forth. For example, there could be a 712 requirement for a set of loudness specifications, a 5.1 soundtrack with the same loudness specs but with different head and tail leaders. There could be a requirement for stereo at a target frame rate that might differ from the 5.1 and 712. And I kid you not, there could even be a mono guide track or deliverable that the marketing team might need. Yes, mono is still a thing in 2023. The list goes on. It's a lot to produce and manage. So how do we deal with this? Well, traditionally, creating those unique versions requires rounds and rounds of manual tasks that take time away from the creative process. These are expensive tasks. The work is done by re-recording mixers sitting on a real mixing stage in a theater. We have a number of them at Skywalker, and a bunch of sound editors that are standing by to assist the mixer in creating these versions. There's all sorts of special equipment involved. Obviously, you have speakers up above, around you, mixing consoles, a lot of computers, a central machine room, and also all the support personnel that kind of goes along with that. It's common for this process to take a couple weeks for a feature film. So our challenge then was, how could we dramatically improve the speed and quality of this process when each show is so unique? Coda. I'm here to talk to you about how we're achieving this all with Coda. We've put all of our institutional knowledge that we've learned over the past 40 years into Coda, all while maintaining top quality sound deliverables. We've used Coda on a ton of titles, about 170 plus titles, including Mandalorian, Moon Knight, WandaVision, and Andor. And we've reduced the time it takes to create versions from 1 day down to 30 minutes. The creatives have embraced Coda because from their viewpoint, the system creates versions that they can't simply do with existing tools given an allocated amount of time. They see great results on time savings. This means the sound team can focus their time creating a better soundtrack for your enjoyment. And with production schedules getting tighter and tighter, and post-production being one of the very last steps in the post-production chain, any time saved is huge for us. So what is Coda at a high level? Coda is a system that takes in a soundtrack and generates all the technical versions or adaptations from it to hit all the different distribution endpoints. All of our core DSP is written in-house. But to do this in any flexible way, aside from a super strict pipeline that has precise inputs, outputs, and steps, we design an intelligent workflow engine. This engine looks at what you're passing in as input, and it looks at what you want on the output side, and it generates it dynamically figures out the best processing path to take. It also reuses mezzanines and intermediate files so that nothing is ever, we're doing efficient processing and not, processing material that we could have reused. So for the workflow engine to know how to arrange the skills, we have this concept of skills in Coda. Each skill represents an ability. This one is a loudness correction. We register it against Coda using a JSON API path, API document. And these skills aren't sound specific. These could be, file handling, encoding, packaging requirements, different output format specification. So it's not limited to DSP in particular. Here's a list of skills that we have. It ranges from loudness correction, true peak, frame rate conversion, encoding, data I/O is our transfer, accelerated transfer network, summing, dynamic range control, file renaming, adaptive downmixing. Because they all implement a common interface, it makes adding new modules relatively easy. For example, if another encoding technology, say from Dolby, comes out, we can easily insert it into our pipeline. We dynamically assemble all these skills to form a pipeline to produce the output deliverables that you want. So for a given set of input files, the pipeline might look like this. So input files coming in on the left, and we figure out, based on what you want on the output, what sort of steps we have to take to get there. We certainly optimize it as much as possible, like I said, using shared mezzanines so that no other process is stepping on each other. The graph might look completely different from another set of input files, but using the same output specification. It basically reacts to what you give it to us, and we figure out the rest. We've kind of abstracted it all away from you. So let's talk about these skills. So what are these skills on a lower level? Well, they're really just Docker containers. We containerized all these components so that we could scale them with Kubernetes. Has anyone heard of Kubernetes here? Awesome. The containers spin up on a per job basis, so they're ephemeral. They spin up, process the audio, spin back down to meet the demands of the workflow. They're never sitting idle. So our compute resources are efficiently used. Separating these components out into different microservices or containers lets our teams develop or improve just a single component of the entire platform without affecting the rest of the chain. The components use semantic versioning. That's just what we use internally. And the benefit is that we could reuse these components elsewhere at Skywalker in our internal processes for internal tools, external tools, and so forth. So as an example, here's a modest-sized job and all the containers it would spin up in Kubernetes. The input is coming in on the left, and all the outputs are kind of flowing over to the right. It's a ton of nodes that actually get spun up in Kubernetes as Kubernetes jobs. In reality, it's just a big, giant graph at the end of the day. Kubernetes helps schedule these containers across multiple nodes, but we're leveraging Netflix's Conductor, which is an open source project that you can find online, to help us execute these workflows. So this giant graph, higher level graph, all boils down into a conductor graph, which looks something like this. It goes from top to bottom. We have an ingress node at the very top that gets files into Coda platform, and then it flows down into our DSP graph here, which we dynamically compile based on your inputs and what outputs you have declared. And then we start to package them, and then we send them off to their destination. Okay, so like I said, Kubernetes helps balance these containers across nodes. Kubernetes helps round robin these containers so that, for example, frame rate conversion ends up on one node, downmixing and true peak on another, DRC, dynamic range and control, and summing end up on another node. And we could also scale horizontally too. So we could just keep adding nodes to our cluster, and then Kubernetes will help us balance and round robin those across all the nodes, which is pretty cool. If we take a step back, we could actually deploy jobs or Kubernetes jobs across different sites. So on-premise, private clouds, public clouds. We actually have an accelerated data transfer network that when the files are done processing in Kubernetes, we actually can ship them to their destination. And a lot of what we do at Skywalker is really, finish the job, but then there's a whole laundry list of people that we have to send those deliverables to. So we've automated that as well. And this is a fun slide. I could actually talk a whole hour on this, but this is our stack from low to high. At our core, it's C and C++, of course. We end up creating a lot of static and shared libraries that we can actually link against to in Python and in Go. We have a lot of C++ code at Skywalker. There's a lot of Python code. Our R&D and ML team love Python. More and more stuff is going to Python. PyTorch is a framework that our ML team is using. More recently, within the past 2 weeks or so, we were looking for solutions for cross-platform apps that is not Electron. So we went with Tari and Svelte, which gives us Mac, Linux, and Windows client-side apps. It's where Rust kind of makes an appearance in our back end here, or in our stack. We have a lot of Go code at Skywalker. It's very quick to compile, super rapid iteration. We end up binding some elements of C and C++ libraries against our Go code so that we could hand off the DSP to more performant code there. Our UI team is using TypeScript and Next.js. Going up the stack, we use in our local dev environments, and in CI, we use GNU Make, of course. Tilt is really awesome. It's an open source project that allows us to spin up the entire Kubernetes stacks right on the laptop. So that entire architecture I'm able to spin up on this thing right here with Tilt. So you could actually bring up all the components for that Kubernetes stack right on your laptop, which is really nice. We take testing very seriously at Skywalker. So Google tests, which was shown earlier in the day. We do a lot of testing in Go, Python. We try to have a sensible code coverage percentage, 80%. If we don't get there, we don't get there, but it's worth a shot. It's something that we strive to do. At the core of our software development lifecycle is GitLab. It's all inclusive. So everything is sort of managed in our GitLab, our private GitLab instance. Every time we push and do a semantic release version number for C++ code, it builds all the static and shared libraries that we could pull into the Docker containers, which ends up getting security scanned by Sneak, and makes its way into Red Hat Quay, which is our container registry. So every time we push code, or git push, or actually tag it, we actually end up running a ton of security scans against the open source manifest as well as the container image. And you'll be surprised how many security vulnerabilities pop up because of that. So we're able to actually, in almost real time, identify what the security vulnerability is, make a patch, and in the base container image, and off we go. So we get 2 layers of that at Sneak and Red Hat. Conductor, like I said, is made by Netflix, so that's what's helping our workflows get executed. You don't have to have Kubernetes to back a Conductor to execute the workflows. You could use curl on a local terminal, and it'll use your compute on your laptop to kind of execute the graph, which is really nice. We use MySQL, good old MySQL for our basic backend. We use Redis as our in-memory store database. We use it as a message conduit between the containers and Kubernetes. We also use it as our caching layer, pub sub models, and all that sort of fun stuff. We have a presence on Amazon, so we use DynamoDB for our authentication layer, which we'll see in the next slide. as we work our way up the stack, we have Terraform, which helps us deploy and version control of all of our deployments for Coda. Kubernetes, we've been talking about the whole time, helps schedule the containers on different nodes. And AWS, we have a presence on there with Lambda, and we've built an authentication layer on top of AWS Cognito, which we're calling Sprocket Auth. We wanted to conveniently aggregate multiple IDPs into a single platform, and AWS Cognito ended up helping us out there, which is really nice. We're using Resilio Resilio Connect to do our accelerated data transfer to Kubernetes and out of Kubernetes to the destination clients. So thank you for listening. We have 3 minutes left, so if there's any questions, feel free to ask.
Check. Oh, hey, that was fantastic. 2 questions. So one is, what is your solution for observability? Because I'm sure things go wrong. You get paged in the middle of the night.
Yeah.
And then secondly, how do you quality control the output? You must have some kind of automated, quality control.
Yeah. Great questions. Datadog is our first one. So we have a Datadog agent sitting on Kubernetes that helps us actually visualize the entire call stack, which is really nice. Go has excellent built-in metrics that we use as well. For your second question, how do you validate the outputs? GitLab, all-inclusive. We could schedule cron jobs. I have a cron job that runs every morning at 2 a.m. And we could validate the outputs of that, writing basic bash scripts, what have you, to assert the output. We'll have a set of golden masters or golden images that we process the graph to, and we assert the output of each sample.
Great talk. When you're doing this containerization, are these individual processes operating on the entire piece of content and then it goes to the next process, or are they kind of more block-based? And separately, are all like the individual movies different? Like I imagine there's some efficiencies you can gain by batching some of these things up across different titles.
Yeah, that's a great question. Our DSP team would probably be more inclined to answer that one. But yes, so we're file-based, so we have access to the entire file. We could seek through the entire file if we wanted to. They operate on them on blocks. And your second question was, I'm sorry, what was that one?
Efficiencies and parallelizing.
Oh, right, yeah. So a lot of that stuff, you notice in the conductor graph, there's, within each horizontal row, there's processing blocks that could be parallelized there. Obviously, there's some pieces of content. It's content dependent, so large action movies with, loud explosions and stuff may be processed a little bit more efficiently. Not as many peaks to catch than a narrative form. So we gain some processing efficiencies there.
Follow-up to the QC question that was asked earlier. Versioning often takes so long because producers want to watch, every single version themselves to make sure it looks good. And you mentioned there are some automated workflows in the pipeline, but I'm curious as to whether that is actually, like on the client side, is that actually accepted? And you mentioned time saved earlier in the whole process. So I'm wondering if actually on the client side that is true, and do they actually still have to watch through every version themselves, or is the automated workflow sufficient for, on the client side for their confidence level?
Yeah, that's an excellent question. A lot of our mixers like to just naturally take a listen to everything in the end, but yes, it has become an accepted pipeline and trusted pipeline at Skywalker. Obviously, we have had a number of titles use the platform. A lot of what you hear on those platforms are generated through this pipeline, which is really cool. So yeah.
Yeah, just quick, I could be probably loud enough.
Sneak.
Yeah.
What
I understand this is all your own stuff. Where's the security malware issue coming in here?
Yeah, so Sneak, in containers, you have a base image. It could be Ubuntu. It could be some form of that, and those inherently have operating system level vulnerabilities. Like Log4j, when that they came out, all of our CI pipelines were bright red. So you end up going in there and fixing every single one of them. We try to use distro lists from Google, distro list containers, which have the bare minimum of OS dependencies in the container images, so that we don't have to deal with any unnecessary dependencies like libcurl or something like that.
Yeah, I see what you're saying. Since you've got third-party dependencies in these distributions, something bad could happen.
Yeah.
Well, I got to say, I am blown away by the complexity of this thing. I mean, it's kind of amazing what you're doing. Now, this example you were showing was basically just for one movie, say, making all the different formats and just having this massive parallel jobs to do all the signal processing.
Yeah. Yeah.
At once.
At once. Yeah.
Wow. In a half hour.
Yeah.
I give up.